All right, we're going to do this related rates problem for a balloon. I'm going to go through the steps, a little bit quicker than I might go if I was explaining it the first time around. This is more of a little bit of a refresher. So, we are given, we have a balloon, spherical. It's inflated at a rate of 12 pi feet cubed per minute. That is going to be our dV over dt, which is 12 pi. We know that because it's feet cubed, and that's how I measure volume. And then it's per minute, so that would be the dt. So in the first question, they want to know how fast is the balloon's radius increasing when the radius is 1 foot. So I know that the time that I care about is when r is equal to 1. And how fast is the radius increasing? They're asking for dr over dt. So I'm working with two variables here. This one, which is volume, and this one, which is radius. So what I'm going to do is take volume and radius, and I want to find an equation for the two of them. I want to relate the two of them. I'm going to use the volume equation. It should be pretty straightforward here. Volume is 4/3 pi r cubed. So what I'm going to do is take that equation, V equals 4/3 pi r cubed, and I'm going to derive it with respect to time. The left side is the more simple side. I get dV over dt equals 4/3 pi. That's a constant, so it comes along for the ride. Then I do power rule, 3r squared. Then I multiply by dr over dt because of the implicit differentiation step. We've talked about that step a lot. I'm not going to go into a lot of detail here, but you should be okay with that step. From there, I'm going to simplify and get dv over dt is the 3's cancel. So I get 4 pi r squared times dr over dt. From there, I just need to fill in what I know. So we know dv dt is 12 pi, so that's going to go in here. So I get 12 pi equals, and then I know I'm going to write my 4 and my pi, just carry those along. I also know that r is 1, so I'm going to write times 1 squared times dr over dt. And then from there, I just need to kind of simplify and solve for the thing that I'm looking for. So I'll rewrite this line, 12 pi equals the 1 squared just, it multiplies away. So I get 4 pi times dr over dt. And then my last line is going to be to divide everything by 4 pi. That's going to give me dr over dt equals 12 pi over 4 pi. So that gives me 3. What units do I have? Well, I take the units for r, which is feet. And then I take the units for time, which is minutes. So feet per minute. So that's the answer to that first bullet point. All right, now I'm going to do the second bullet point here. So this asks how fast is the surface area increasing at that same instant. So we're allowed to use the information from the previous problem. So we're going to look at what we have and what we need, kind of go through the same process as the previous one. So I want to know dSA dt equals what? And I know that dr dt equals 3. That's from the previous one. Remember, that's what I solved for right here. And I also know that dV dt equals 12 pi. I can use either or one or both, whatever. So what we're going to do is use the surface area equation. Notice the surface area equation says 4 pi r squared. So what I can do is write that. SA equals 4 pi r squared. And notice there's no volume in this one, so I don't actually need to use this right here. At least I don't think I do. So I'm going to go ahead and start with this. I'm going to go through the same process that I went through here. We're at this line right here. What did we do? We derived with respect to time, so I'm going to derive this with respect to time. So left side is the simple side. dSA dt equals, I'm going to do power rule, 4 pi times 2r, and then I'm going to do my implicit step, which is dr over dt. Then I'm going to simplify, and I'll come up here. So I get dSA dt equals 8 pi times r times dr over dt. So from here, I'm going to go ahead and just figure out what pieces I need to plug into this in order to get the rate of change of the surface area. Because again, that's what I'm looking for, the rate of change of the surface area. That's why I went and took the surface area equation and took its derivative with respect to time. So notice I got 8 pi, I need the radius, and I need the dr dt. Well, I know that the radius is 1 because that's the instant that we were talking about. And I know that at that time the dr dt is 3. And that's true because that's what I found in the last problem. So we're going to write dSA over dt equals, all right, 8 times pi times the radius is 1 times the dr dt is 3. So I just simplify that out, and that gives me 24 times pi, and that's my answer for that one. The one thing that I want to comment on is that's the end of it, end of the problem, but I do want to comment on something that hopefully should make some sense with regards to this problem. So what should the units be? Well, it should be, let's see, surface area is feet squared, t is minutes, so it should be feet squared per minute. I want to show you that that's actually what I have here. What are the units of dr dt? It's feet per minute. What are the units of r? It's feet. Notice they were multiplied right here, and this is a constant. So when I multiply these two, I get feet times feet per minute, which gives me feet squared per minute. And that actually should work out with any related rates problem. I could have shown that happening here, but we're dividing and it was a little bit messy. So you should give units with your answer. And I'm sorry about this little thing. The iPad was picking up my palm. So yeah, hopefully you are good with this type of problem, and we'll do more soon. See ya.